Three of the reactions that occur when the paraffin of a candle, typical formula C21H44, burns are as follows. One is complete combustion forms, CO2 and water vapor yields. Incomplete combustion forms CO and water vapor. And then the third equation is some wax is oxidized to elemental C, soot, and water vapor. So they want us to calculate the delta H combustion for each reaction. And they want us to assume that per 1 mole of C21H44, the delta H formation for that is negative 476 kilojoules per mole, which we have right here. And these are the values that we're going to need, the delta H formation values for the equations that we're going to write out. So for the first one, they want the complete combustion that forms CO2 and water vapor. So the paraffin, which is C21H44, undergoes combustion that yields CO2 and water vapor. And so to balance these, we're going to need a minimum of C21 and 44 H's. So we're going to need 22 minimum here and 21 minimum here. So that makes 21 times 2, 42 oxygens, and here is 22, so 64. So here we have 2, divide that by 2, so 32 oxygens. And then we do products minus reactants. And here's the delta HF values here, so we'll use those. So 22 times delta H value for H2O, which is negative 241.826. Add that to 21 times CO2, which is negative 393.5. And then you subtract O2's delta H formation value for that is 0, so we don't have to include that. And then for C21H44, it's negative 476. If you calculate all that together, you should get negative 13,107.67 kilojoules. So this is the delta H combustion for a complete combustion of the candle that forms CO2 and water vapor. Now is the time for the incomplete combustion that forms carbon monoxide and water vapor. So again, C21H44 undergoes combustion that yields carbon monoxide and H2O. So we'll need to balance this as well. So we need a minimum of 21 C's and a minimum of 22 hydrogens. So now we have 22 oxygens, 21 oxygens, 21 plus 22, so that's 43. So here we're going to have 43 divided by 2 of oxygens, since these two will cancel out and we're going to be left with 43. So now we'll do the same thing that we did with the last equation. So 22 times negative 241.826, add that to 21 of carbon monoxide, which is negative 110.5, subtracted by oxygen is 0, so and the C21H44 is negative 476. You should calculate that. So and I got negative 7164.672 kilojoules. That's for the second equation. That's the incomplete combustion that forms carbon monoxide and water vapor. And now for the last equation, we're doing some wax is oxidized to elemental soot and water vapor. So again, C21H44 is oxidized to form C, soot, which is graphite, and H2O. So here we have to balance this again. We need a minimum of 21, and we need a minimum of 22 here. So 22 oxygens, so we need 11 here. 22 H2Os, which is negative 241.826. Add that to 21 of carbon graphite, which is 0, so you don't have to add it. and then subtracted by -476, which is this, the candle. Then 241.826, add 476 to that, and you're going to get -4844.172 kilojoules. This is for the third equation, which is the when the some wax is oxidized to soot and water vapor. So the third, or part 2, asks find the Q in kilojoules when a 354 grams candle burns completely. So we found the amount of kilojoules that is used per mole. So we'll convert that amount or mass that we have, 354, to moles, and then we can multiply it by the kilojoules of the complete combustion, and then we'll get our value. So we have 354 grams of the candle, and what's molar mass of C21H44? Okay, that is 296.57 grams per 1 mole. So we cancel these, and then 354 divided by 296.57. So this is how many moles we're burning. So this is how many moles we have, and then we'll do 1.1936 moles multiplied by the value that we got for the complete combustion, which was -13107.67 kilojoules per mole. So these two moles cancel, and then we're going to be left with kilojoules. So if you do this, 936 multiplied by 13107.67, you'll get -15645.31. And that's the amount in kilojoules per 354 grams of the candle. Okay, so now it's saying find Q when 2.91% by mass of the candle burns incompletely and another 1.05% undergoes soot formation. Okay, so we have, and they're referring to the mass above it, so 354 grams. Okay, so 100 minus 2.91 minus 1.05. Okay, so 100 minus 2.91. Okay, so this is the percent that's going to burn incompletely. This is the percent that's going to undergo soot formation, and this is the percent that's going to go complete combustion. So convert the percents to decimals, and so let me get rid of this. Or rather, I'm going to keep it. So 0.9604 multiplied by the mass of the value above, 354, and we'll get 3. So this is the mass of the candle that's going to burn completely or combust completely, and then this is the amount that's going to combust incompletely, 3.717, and then actually this is the one that's going to be combusting completely. The one above it is going to be undergoing soot formation. So this is going to be 10.3014. So these are all grams. And we'll convert these to moles because we're going to use these as basically conversion factors by multiplying them by the values that we got in part A for part 1, 2, and 3. So per 1 mole, it is 296.57. And this is for each one, so I'll just do it for each one of those right away. 0.98 divided by 296.57. So for this one we have 1.1463 moles. And then we have 3.717 divided by 296.57. And we get 0.01253 moles. And then for the last one we have 10.3014 divided by 296.57. And you'll get 0.034735. And now we can get rid of these numbers since we have the moles. Now these moles are going to serve as conversion factors, as I said earlier. So this is going to be for equation 1, this is going to be for equation 3 for 2. So 1.1463 multiplied by, I need the numbers again. So negative 13107.67, and then 0.01253 multiplied by, that one was the one that goes under soot formation, so a third one, so negative 4844.26. And then the last one was 2.91, so that's for the third equation. So 0.034735, and we multiply that by negative 7165. I'm going to put these in parentheses so that they don't look like we're multiplying and subtracting at the same time. Okay. And now we calculate and then we add them together. 463. So this is how much for the perfect combustion. This is how much we have for the soot formation. And then this is how much we have for the incomplete, the one that forms carbon monoxide, 248,876. And now we add them together. I got negative 15,348.315 kilojoules. So that is the answer to part C.